is Steam video games recommendation system. We are going to talk about the datasets, the three methods we tried, and some evaluation and real user testing. We used two datasets. The first is a dataset containing 30,000 games. The fields are game ID, tags, description, etc. The second dataset is a user review dataset containing 700,000 user reviews, hours played, and recommended or not. We did some cleaning and transformation on both of the datasets. Specifically for the game datasets, we concatenate title, description, tags into one single document. We next use NLTK to remove the stop words and extract keywords. Finally, we construct a sparse bag of words matrix to represent the text description of the games. For the user dataset, we filtered out users with more than 30 games and sampled 1,000 users for easier computation. The first method we tried was frequent pattern mining. We used FP growth algorithm to generate 77,000 frequent item sets with the mean support of 0.015. Even though the support seems low, but considering the large amount of games and users, we considering this number would imply enough overlap on users' game item sets, and thus an indicator for strong associations. Further, we generate 1 million association rules with mean lift as 1.2 because confidence score can be misleading sometimes. For evaluation, we sampled another 300 users and take out 1/10 of each user gameplay records as prediction targets. We first applied association rules to the known game sets and filtered out candidates using these rules. Finally, we used lift score to rank our candidates and recommend the top items. However, this method only gave us a F1 score of 0.049, which means the system hardly generates correct recommendations compared to the ground truth. We concluded a few reasons. First, some game items have very high frequency, so the system tends to recommend the high frequency items even though the user might not want them. Second, it only depends on the game sets of the user, not the game content itself. And finally, the system only gives binary recommendations decisions. It didn't quantify the user's preference at all. We tried was clustering. We want to use gaming times to better model the similarities between users, but there's a problem with the user matrix. We have more than 30,000 games, so the user matrix will be very sparse, which is not good for clustering because of the cursive dimensionality. So we transformed the matrix columns from individual games to the game tags. Now the matrix has a better shape. We used k-means clustering and selected k equals 39 based on the SAC and the silhouette coefficient. As for the recommendation, we used the same test set as the previous FP method. For each cluster, we sum up the user vectors into one vector and selected the most popular game tag. From there, we recommend the top K games for this tag. We finally got a F1 score of 0.02, which is worse than the previous FP model. We think the reason might be, first, the results are biased because the skewed user gaming time. And second, the model only recommended games under one most popular tag. Collaborative filtering uses Pearson similarity to measure the similarity between users. The problem with this was that the user matrix was too sparse. Content boosting means using the bag of word matrix to predict unknown game's gaming time. The bag of word matrix looks like the table on the right. Each row is a game and each column represents a word. Each entry is the frequency of the word in a given game description. And the CBCF combines previous two methods by adding an extra layer to predict a full user matrix, so that we don't need to worry about the matrix being sparse. We did this step by using the SGBoost regressor. The final result showed that CBCF really improved the performance. With 40 hours error and a standard deviation of 162, we believe that this recommendation system can generate reliable recommendations. We also did a user testing with a real user account. This is account information with games and the hours played. And we generated a few games recommendation. This games, the system says you'll be playing 100 hours, and the Steam platform also thinks so. think this game is relevant to you, and also for this game. But for this game, the system gives 0 hour predictions. And Steam also think this game is not relevant to you. Thank you.